Hi there. What we will work on in today's video is logarithms and converting from exponential form to logarithmic form. So logarithms are used to solve problems where our variable is in the exponent and we're not able to get common bases like we were in some previous sections. So it's going to be important for us to be able to transfer or convert from exponential form into logarithmic form and back. So first of all, let's talk about exponential form because you're probably a little more comfortable with this. When we look at exponential form, we know that b is our base, y is our exponent, and we'll call x the result. So when we turn something into log form, notice what we do. We say log base b of x equals y. And I want to show you something because I think it'll be helpful. Look at this. B to the y equals x. B to the y equals x. It makes an e like exponential form. So if you take that, that might help you. Log base b of x equals y. That's how we say it. So let's go ahead and let's do some conversions together. So we have log base 4 of 16 equals 2. And so I want you to think as we put it into exponential form, the base to the exponent equals 16. 4 squared equals 16. And that's what that looks like. Converting from exponential to logarithmic form, we have 6 to the third equals 216. So log base 6 of 3 equals 216. Okay, log base 6 of 216, log base 6 of 216 equals 3. So log base 6 of 216 equals 3. So you'll notice it's the exponent on the other side of the equal sign. Okay, so what I want you to do is I want you to stop the video and I want you to convert these into exponential form and these into logarithmic form. Okay, and it might be helpful to make this little e. Okay, let's see what you can do. Pause that video. Okay, so I did the exponential ones for you. Hopefully you did okay on those. And now go ahead and make sure you do the logarithmic ones, okay? And let's see how you do on those. Once again, pause the video. You're going to have to get really comfortable with this. Okay, so check your work here. Hopefully those conversions were okay. The reason we have to do these conversions is because they're going to help us solve equations. So let's go ahead and take a look. I have two examples for you here. So if we were asked to evaluate this log, we're basically asking you, what does this equal? So what we do is we put it into, we set it equal to y. Okay, so we set it equal to y, and then we convert it into exponential form. So 8 to the y equals 64. And then, remember what we did in previous lessons, we try to get these two sides of the equation to be expressed using the same base. So we set 8 to the y equal to 8 squared, and now we can set those exponents equal to each other, and we get y equals 2. Okay, I have another example over here. So same idea, we set it equal to y, and then we do that conversion to exponential form. That's what we do when we have a single log on one side. So we have 9 to the y equals 27. And of course 9 and 27 are both powers of 3. So we set them so that their bases are 3. Then setting their exponents equal to each other and solving. Okay, so you're going to go ahead and you're going to try to do that. I'll get you started on the first one anyway. So remember, we set this equal to y. We're going to convert it to exponential form because we have a single log on one side. So we have 3 to the y equals 243. And that's one of those numbers that we should start to get to know. So 243 is 3 to the 5th power. So again, we have 3 to the y equals 3 to the 5th. Therefore, y must equal 5. Okay, so go ahead and do the best you can on these 8 problems now. We did the one. Pause the video, and hopefully you'll do okay. Okay, in case you wanted to just check in, I did problems 2 and 3, so hopefully you got the same answers and you'll be able to finish the next 6 problems pretty easily. Once again, pause that video, do these problems, and then check back. All right, so take a look at your answers. One that I thought you might have a little trouble on was this one. Remember, you have to bring this 3 to the numerator, and then it's to the -1 power. Okay, so I thought maybe 5 might give you a little trouble. Okay, when you feel comfortable and you're ready, let's move on to the next section. So here I'm going to teach you how to solve log equations. And what we're going to be looking at are 2 scenarios. When we can't evaluate the log like we did in the previous situation, but specifically when we have a log on one side versus when we have logs on both sides. So when we have a single log on one side, and we're not able to express it, we're not able to do anything here, we're just going to convert it into exponential. So 5 to the third equals x plus 1, and now we're just going to solve that. So 5 to the third is 125. Subtract your 1 from each side, we find that x is 124. So on the next one, again, what we're doing here is we have a single log on one side, we have a constant or something on the other side. We're going to convert it to exponential form. So we get 3 to the fourth equals 2x minus 1. And now we're simply going to say, oh, well, 3 to the fourth is 81. So 81 equals 2x minus 1. Add that 1 to the other side. We get 82 equals 2x. Divide, divide. X equals 41. Oops. So that's a little bit different. Okay, a little bit of solving there. The second scenario we have is when we have a log expression on each side of the equation and nothing else, okay? We can't have, like if we had, plus 5 here, this rule would not work. So it only works when we have a single log on the left and a single log on the right. What's wonderful is we just cross out the logs and solve the equation that's left. Okay, but it really is a very specific use. We only have log base 8, in this case, of something equals log base 8 of something else. Cross out those logs, we're left with 2x equals x plus 8. This is simple, subtract, subtract. You get x equals 8. Okay, so go ahead and look at these next 3 problems. And I want you to think about which kind it is and go ahead and solve them. Stop the video, use the examples from up above, and let's see how you do. Alrighty, take a look at the work here. I thought maybe on number 12 you might have an issue. So remember, when we have a value raised to a rational exponent, we can raise each side to the reciprocal, and I didn't write it over 1, but the reciprocal power on each side, canceling these exponents out, which isolates the b. Okay, so I did think 12 might get you. Other than that, hopefully you did okay. Have a wonderful day, everybody.